This is question number 31 on the January 2017 Algebra 2 Common Core Regents. And this is a probability question, as well as an inference question when relating to statistics and probability. So we have the results of a survey of the student body at Central High School about television viewing preferences are shown below. We have it split into males and females, and we have the polling, which was comedy series, drama series, and reality series. So this means they polled a total of 490 students. Of them, 230 were male, and 260 were female, and the results are broken down as follows. We also do have the totals for each type of series. That could be useful, but let's see what the question is. Are the events student is a male and student prefers a reality series independent of each other? Independent of each other means that the answer to one does not depend on the answer to the other. And you can go through this with a formulaic solution, but we actually think there's a much easier way to do this, which is actually just to figure out the probability that somebody prefers reality series and the probability that a male prefers reality series. If those probabilities are the same, then the events are independent of each other, because it means that whether you're a male or a female, the likelihood of preferring a reality series is the same. If the probabilities are different, then the events are not independent of each other, because it means that the answer to whether you're a male or female will affect your answer to whether you prefer a reality series, obviously because the probabilities are different. So what we want to do here is start by getting the probability that a student likes reality series. And what we do is we look at the total students that preferred reality series, which is 180, and divided by the total students polled. Remember, probability is the number that satisfy our condition over the total number, the entire population that we're testing. And grab our calculator here and do 180 divided by 490. And we got 0.367. And that is the probability that a student in general likes reality series. Now what we want to do is test the probability that someone is a male and likes reality series. Basically, we are considering, well, this isn't necessarily the right notation actually, because we're not really testing that it's somebody who's a male and likes reality series out of the total. We're actually testing that somebody likes reality series given that they are a male. So let's just look at the male portion of this, because we're only interested in the probability that it is a male liking reality series. So that would be 70 out of a total of 230, because now I'm only interested in the male probability. So let's do 70 divided by 230. We got 0.304. So it appears that males are less likely to enjoy reality series, which would make these two events not independent. So we need to justify our answer. Since the probabilities of liking a reality series, and since that probability is different for males versus the entire test group, the events are not independent. And that's your justification. That's as far as you need to go on the justification. If the probabilities were the same, then we can conclude that the events are independent and that being a male has no effect on your preference to watch reality series.